Again. Testing. 1 second, we have technical difficulties.
Test. Okay. So it looks like my audio is working. Can I have someone on Twitch just confirm for me if everything is, oh, it's laggy. Yeah, it's laggy a little bit, but that's all right. We'll get that sorted out. Someone on Twitch, are you able to hear both of us? And is the audio okay? Twitch or YouTube, either way. All right. Wait, is my okay? Yeah, my webcam's there. Okay. So, hello everybody. Um, Welcome to the first Veloren Code Reading Club. So this is a little project that we're trying. And actually, Zester, can I get you to do, or if you're doing gameplay, I think 720 would be best, just so we get like a little bit of a better frame rate. But for code, it should be good at 60, and I imagine it'll go back up to. So for right now, it should be good. But anyways, we have a lot of technical difficulties that we're going to work our way through. But the objective of um, this little meetup, this little code reading club, is for some of the core developers of Veloren to be able to talk about the code that they've worked on, the foundational code, sort of walk through the architecture and explain what's going on. And so for this first run, we're going to try having a little session about the Site2 system that Zester was working on. And so how it's going to work is we're going to start by sort of explaining what this system is. We're going to dive pretty deep into some parts of the code. And by the end, hopefully, we're going to be able to implement a small feature and kind of see what some stuff looks like. Um, and we're just sorting out some quality things right now. So Zester, I imagine, um, so it's coming. It looks like it's coming through like lower quality. So maybe if you switch it down to 720p, that might be a little bit better. Um, so yeah, we're just getting some stuff sorted out. We're just streaming over Discord, so we're figuring out how to make this work.
Reduce quality to increase quality, right?
Yes. Or instead of stop streaming, if you just click the green screen, yeah, and then right here you should just be able to change quality. So let's try 720. Okay, so lower, but it is better. It is better. We can now see words. Okay, cool. So I'm just gonna move my camera over to the side, so hopefully we can get more view of the code. And so starting out, let's do a little bit of an introduction. So for myself, I'm Angel and Fira. I am the meta lead of the Veloren project. With me today, I have Zester, who was the original founder of the project and has done a lot of work on a lot of like world simulation, a lot of like backend systems and everything like that. And Zester, if you want to give a little bit of an introduction about yourself as well.
Yeah. I I spend too much time writing code for Veloren.
Yes, not
Yeah.
bad.
Today I'm going to attempt to rather poorly explain some parts of the upcoming overhaul to the site code.
And so just a little bit of an introduction. What does the site code so what's its goal? What does it accomplish, and where does it sit in the project?
So right now we have various things in the world, larger structures like towns and dungeons and castles, and that's all well and good, but the way they're generated is it's a bit clunky, and all of them are generated in very distinct ways that don't really relate to one another. So, for example, the town code treats houses as just a series of bounding boxes that are placed at random near to the center of the town. And it's quite hard to then reason about those bounding boxes and think about where to place other elements. And so really the goal of this overhaul to the site code is to unify everything under one one single system that's going to allow for us to build more complicated procedural sites that have different features and so on, and also to mix and match between different kinds of sites. So you might have a site that has elements of a town, but also looks a bit like a castle. Maybe it's got a boundary wall or something. So yeah, it's still very much in progress. So I'm going to be spending a lot of the stream saying, I don't know why this is here. That's bad. I need to change that. So I apologize in advance about that.
All good. And so I'm going to, just before we get started, can you go to screen? Is it like if you do screen and then go to 15 frames per second, is that possible? Stream quality 15. Okay, I think this will make it a little bit easier just to make the text all good and stuff like that. But so we'll dive in. I'll let you take over what you want to, or what you think you want to cover with the sort of just like walking through parts of the code. And for people who are watching along on Twitch or YouTube or in the in our Discord server, if you have questions as we go, put them in chat, and I'll ask Zester at the end of this like little section of walking through the code. And so I think what we'll try and do is like do a little bit of we'll do a walkthrough first of all. We were talking about potentially having some time to implement a little bit of a feature and just kind of see what the process looks like behind that. But depending on how far we get with like questions and stuff like that, we may or may not get around to implementing the feature. So Zester, I'll leave you to it.
Yeah, so first of all, I'd just like to check that everyone can actually see the text. Hope it's not too
Yeah, it should be good now. I
bad.
think the size is good, and I'll make sure on Twitch as well that I was doing well.
Okay. So I'm going to assume that people that are listening in have a variety of levels of understanding of things. I'm going to assume that you have at least a broad idea of what Veloren is and what's sort of going on in the game, and also that you have a sort of a beginner's knowledge of Rust. But I'll try not to assume too much knowledge. So to start off, we have the world generation system. Where best to start with that? We have the world crate in the root of the repository, and it is in charge of working out how to turn the original starting point of the world generation system, which is the seed, into a world that you can actually see in front of you. So there are many different layers to that. The first one is all of the stuff that happens during pre-generation. So, for example, prior to the game starting, we do things like erosion simulation, but we also do things like river formation, and we also think about where trees are going to be placed and so on. And after all of that, we also work out where sites are going to be generated. So where we're going to find towns or dungeons or caves and things like this. I'm not really going to be talking too much about how we choose where to generate them. More, I'm going to be talking about how they're structured in their own right. So this is what the Site2 code covers. So it's sort of a two-part operation, really. So that means there's an element of the site code that runs when the game starts, and we're doing initial generation. And there's another portion of the code that runs in real time whenever a player walks into a new chunk and tries to generate it. And as you'll see, what happens is we want to sort of come up with information prior to the game starting that tells us the broad strokes of how the world should look and how elements in the world should look, but they don't give us really minute details. So we're not looking to define the structure of every single block that appears in the world. We're just looking to define roughly where various elements are. and then we'll fill in the details in real time as and when we need that information. So where to start? Yeah, it's all clear, is it? Good. Okay. So to start with, we have our main struct that contains all of the site information. So this is the information for one particular site in the world. So that could be a single town, or it could be a castle, or whatever. As I mentioned previously, in the old site generation code, we had various different independent ways of generating. So I can show that to you now. We basically had an enum with all of the different kinds of site that could appear. So we've got a settlement, which is basically just a town. We have a dungeon, we have a castle, we have a giant tree, which you may have seen in the game or maybe not, depending on how much exploring you've done. We also have this refactor site, which is currently just used as a proxy for the new code. This is all going to be gotten rid of eventually, but for now, the new site code is basically being implemented as an extension or a variant of the old site code. But the new site code looks rather different. We don't have this enum, we don't have distinct classes of site. Everything's kind of unified in the same place. So the way we do that is we try to structure things by placing things on a grid, a tile grid, we call it. So this tile grid is composed of tiles that are each 6 by 6 blocks wide. And currently it's just a 2D grid. We don't have any 3D information yet. But the idea is that a single building or a road, castle wall or something will occupy a set of tiles. And then when we come to generate a chunk, what we do is we take a look at all of the tiles that overlap that chunk, and we invoke the generator of all of the plots, as we call them. So all of the buildings that overlap that chunk and own those particular tiles. So, for example, let's just do a little illustration. So we might have our tile grid like this, and we get an incoming generation request for a particular chunk, and we find that that chunk fits over these tiles here. And it might be that these tiles are owned by, let's say we have a house. We might have a house in these tiles here. We might have a road in these tiles here, or we might have some other element elsewhere. So the point is that we go through all of the tiles that are within range of this chunk, and we take a look at all of the buildings that are associated with those tiles or are owned or are owning those tiles rather, and then we invoke their generators. And what that means in practice is that every kind of building got its own generator. For example, we can go to the house generator here, and it implements this particular trait called structure. And structure basically just provides us with a common way to define a structural element of a site, and a way to tell the generation code how to place elements of that site into the world. So we get given a few parameters here. first of all, is the site it's part of. Next is this type called land, which allows us to query information about the world, for example, the altitude at a given position or whatever, the altitude of the surface. And then most importantly, we have this type called painter. And this is something new to the new site generation code. And it allows us to paint elements into the world in the same way that you'd paint them with an API, sort of like JavaScript's Canvas API. So you have the ability to do things like paint on cubes, or you can paint on a cylinder or a sphere. And you can build up your structure using these various elements. There's a bit more to it than that. See if I can.
So while you're typing here, one thing I was sort of wondering about is when you define or when you implement structure, is that able to work on things that are like houses, but also things that are like roads, where houses are structures that sort of get placed onto the land, whereas roads are built into the land?
Yeah. So roads currently are generated slightly differently for reasons I won't go into here, because they need to do something kind of unique, which is that they need to stick to the land rather than just be built on top of it. It might be that we can move them to work a bit more like this later on. But for things like houses or also castles, they also implement this. And you also have things like Dungeon, which also implements this, although Dungeon is currently working a bit differently for other reasons.
Okay, and so if I were to come up with some arbitrary type of structure, and so we have like castle, we have dungeon, we have house, but let's say I wanted to do like farm, barn, or something like that, then I could essentially like create this impl, and then all of my logic inside of there would be like pretty nice and self-contained for that thing.
Yeah. So the idea is that the generation code for each particular element goes in its own file, and you can edit them all independently.
Okay.
So Painter uses this technique called CSG, or constructive. You have to excuse me, I've got a bit of a stutter.
Hey, no worries.
Constructive solid geometry. It's always the S words that get me. So the way this works is that you can build up complicated structures by combining more simple elements. So, for example, you can see here we've got a complicated shape that works by combining this cube and the sphere and the cylinders. But the way you combine them is quite important. We have these operations here that are used to combine them. So these operations are basically a set operation. So we can take the union of two shapes, or we can take the intersection of two shapes. Those of you that have a bit of experience with any kind of CAD software, or maybe some vector image editing software, will probably be somewhat familiar with this concept. As you can see, we've got a few of the operations here that we can perform. And Painter allows us to do this too. So a good example of this is in the newer workshop element that I've been working on, where we can do things like, let's get a good example.
So as you're finding that, what you're meaning is that are you able to combine different colors together to make an output with this technique, or are you able to combine multiple sort of like 3D shapes together? So for example, if you were making like a house, you could use this technique to make it seem more than just like a few Lego pieces put together.
Yeah. So rather than creating a house by just creating lots and lots of bricks and building them on top of each other, You'd instead create a house by defining the overall structure of the house and then removing elements in it to carve out the inside and carve out the windows and things like that. And the CSG technique allows you to do that in quite an ergonomic way. So just to show you how this looks currently, I'm going to enable the Site2 generation. So the way you do this as of a week ago is you go into the assets directory, into the world directory, and there's a features.ron here, which allows you to turn on and off various things. So there's the Site2 flag here, which is change it to true. And then you just need to restart your local server or restart the game. As you can see, my local server is running again now. So I'll just connect to it now. Okay, it's online now. So my client's going to be connecting to it. And if we enter the world, you can see it looks kind of the same as it did previously. But now if we look on the map, we have, no, that's not one, that's an old site. We've got a new site over here. So this is the new site. It's not got a proper name yet. It's just called town because that's all stuff that's yet to be done. But we can set a waypoint and fly over to it.
The quality is actually working pretty nicely on the stream right now.
Oh, that's good.
And so we're going over to a town right now, but what might be some other examples of places? So we've seen like castles and houses and stuff like that, but what might be some other examples of things that you might see around the world that use like this new type of technique?
So really anything, to be honest, anything you want to construct in the world that looks, how do I put this? Looks like it's got low entropy. So trees would not be a good example of this because trees are quite chaotic. You can see here, if you were to try to carve this tree out of lots of different intersecting elements, you'd end up needing to make lots of different holes and carve them into each other and take the union in, and also the intersection of lots of different shapes. And it just wouldn't work particularly well. But for things like a house, where it's got quite a fairly regular structure, it's pretty much ideal for that sort of thing. You can see these are how the new towns are looking at the moment.
Also, so when you move your camera, it does get a little bit laggy. So like the more that you keep your camera not having to update a lot of pixels, then it looks pretty good.
All right, okay.
Yeah. Okay, so like if we take a look at this house right here, well, compared to what I've seen before, what I'm seeing here is that we have sort of like two different levels, and then the top part is a lot more complex, where we have like different sections that are put together, and then on this side of the house that we're seeing right now, we have like a lot of different pieces sticking out. So what does this look like inside of the system?
Yeah, so currently a lot of the house generator was written prior to me creating this new Painter API. It's written by James, and so it's a lot more wordy than it would otherwise be. I reckon it's probably the case that we could half the size of this generation code now, but it's pretty much using the same technique. So the way this works is we have a set of elements that we call primitives, that are these basic shapes that we start off with. And then we combine the primitives using these operations like union or intersection. And then we get a new primitive out of them. So the way this is represented in code is right here. So we have a primitive that can be one of these, and there are lots of different options here. But a primitive can either be an AABB, so which is just a bounding box, so a square, or a cuboid, or a cube, or something like that. Be a pyramid. It could be a cylinder, a cone, a sphere, all of these basic shapes that you'd expect. But it can also be a combination of two different primitives. So, for example, and in this case is basically our equivalent of the intersection operation. So it's an example of this here, where we're taking the intersection of these two shapes and creating a new shape out of it. So we might say that this one is our cube, and this one is our sphere. And we're taking the intersection of them to create a new shape, an entirely new shape that's just sort of arisen as we've needed it.
So,
And there are various operations.
or I was just thinking, so we have these like very primitive types of things, but I am curious that when we're putting them together into a house, like I would sort of imagine that maybe if I was going to design a house through this method, I would be feeling like I'm building with Lego in a lot of ways, where I put a lot of sort of cubes down in one area, and then maybe I want like a window to be more circular, so maybe I'll use the maybe union of some type of sphere and a square. But what's the sort of thought process that you go through while you're working on this?
I think a good start is probably to play around with the system a bit and get some practice with it. Sort of work out what sort of shapes it's possible to make. Usually there are a few tricks that you sort of discover in time. So, for example, if you want to make the bounding wall of a house, you might start off trying to construct the four walls as independent bounding boxes. But an easier technique is to just use one large bounding box and then take the difference with a smaller bounding box that's inside it. And this way you're using only two primitives to create the four bounding. So as an example, you'd start with the outside bounding box, and then you'd cut out of it the inside bounding box. And then all of a sudden you're left with your four walls, and you've done that with only two primitives rather than the four that would be needed if you were going to actually assemble it out of individual pieces.
Yeah, I see. I
So,
see. Where you go?
so
Yeah.
my method usually is to draw out the structure I'm looking to create, and then try to think about how I can segment that into smaller pieces in my mind. So I'd start off thinking of a house, and I'd think about the lower part of it and the roof as independent things, and then I'd work out how I can create that roof. And then the roof needs a chimney, so how can I create the chimney? Well, I could create a chimney by creating a cuboid, and then cutting a smaller cuboid out of the inside of it, so you end up with a hole in the chimney, like so. There's also a primitive called a ramp, which is basically what you'd expect. It's just a ramp that looks like do not disturb. It's a ramp that looks a bit like this, where you've got a slope on one side, and what you can do is you can take two ramps and use their intersection. So you've got the second ramp here, and then you can subtract one from the other, and then you just end up with the side of the roof.
Interesting.
And then you can do that twice on both sides, and you end up with a roof shape. And then you can union that with your chimney, and then suddenly you've got yourself God, this drawing is terrible. And then you've got yourself a chimney that sits on top of the roof.
Yeah.
And you
So
can see that from maybe only a dozen shapes, you can start to build up a structure that's still relatively complicated.
you're sort of describing like a process here where you follow, like you give it a lot of steps to follow to be able to make something, like something very specific. But then how does this sort of or how can you take this method and expand it out to create a lot of like diverse things that all use the same rules but all look a little bit different? So for example,
Yeah,
if you're creating a
so
town, you're gonna have like 20 houses or something.
the main way you do that is parameterize it. So as an example, in the house code, we have this function here that gets called, it's called generate. And this function gets called prior to the game starting. So previously I mentioned that when the game starts, we generate sort of the structural information of the world. So information about which houses are where and maybe how tall they are, but we don't generate every single block because that's the job of the CSG logic here. But we still might have some useful information we want to generate, like some information about how large the house is. We also might want to generate information about how many levels it has, so the number of floors. We also might want to generate information about various attributes of the roof, like this one controls to what extent a roof will overhang. So you can see that this roof here has got a bit of an overhang. And this one doesn't really. It's just going up to a single eave. So you can generate that sort of information beforehand, and you can also see also generating the roof of the house here. And these things are generated kind of randomly, semi-randomly. So you can see with the roof color, for example, we've basically just got a list of colors, and then we're choosing one using a random number generator. So that's fairly conceptually simple. We're trying to describe a house using the broader structural information, and then later on we're taking that structural information and using it to inform the generator that's going to actually emit all of these primitives that can be combined together to create the final shape of the thing.
Okay. And so if I understand like the Site2 code correctly, sort of like from beginning to end, so we start when the world starts generating, it will have a lot of different tiles that have been assigned certain locations, or like rather like a house will be sitting on this chunk, and then once the world generation comes around to design this like these several chunks or whatever, then it will say, okay, we need to build a house, so it will follow the procedural rules that this structure has, and it will be able to add a little bit of diversity to it. But like the Site2 code is really encompassed in like we have these tiles already set out, and this is what we're putting on top of it. Not really, or like it doesn't care as much about figuring out which tiles or how the tiles get assigned and stuff like that.
Yeah. So what we're talking about at the moment is how you go from the structural information to the information about which blocks should be which color or whatever. How you come up with the structural information to begin with is a whole separate topic, which doesn't really have much overlap with this. So I'm probably not going to explain it in this kind of session because it's still not very complete as it is. For example, you can see that the structure of the towns is not particularly complicated. They have roads, they have sort of squares and things like that, but there's no real structure beyond that. And a thing that we probably want in the long term is to have maybe like a central high street, maybe a town hall, different things that appear out of that. But that's not currently a focus of code reading session, really, because
yeah, we're just staying it on sites.
Yeah.
Okay, so right now we have about like 20-ish minutes left, and so I think just kind of like looking. So we have a few questions that I can ask from chat first of all, but then I'm thinking for diving a little bit into some of the code and like just writing a little bit of stuff. Do
Mhm.
you have anything off the top of your head that we can try implementing, or I think
Yeah, so I have a
or
few ideas.
yeah, okay, perfect.
Um, I was going to say that we could be a bit adventurous and try to implement a windmill, but that might take a bit of time. So I'll start off with implementing a cube and see where we go from there.
All right, sounds good. Also, can I get you to go back to Discord and then just change to 30 frames per second briefly and then back to 15 just because for whatever reason it locks it like after you show some gameplay it locks itself like down to like well okay actually okay I think go back to your code for a second. Okay, that's fine. So while you're getting some stuff prepped here, I'll ask some questions from chat. So first of all, do the new houses have staircases finally?
They do. I'm sorry, this is probably going to change the frame rate
I'll
back,
tell you if it
isn't it?
does.
But let's type on. This is all thanks to James. James did a lot of the work on the new house generator, but there are actual staircases. Um, they're still quite empty. There's still a lot to do in terms of populating it with furniture and stuff like that. Um, but I think it's a nice start regardless. Um,
Yeah, it definitely like gives you so yeah, we can now access the second and third floors or like let's say there's like a really tall building or something like that, then it could have the instructions to be able to like really make it a place that you can go into and explore a lot more, I guess.
yeah,
Um,
yeah. There's merchants don't currently work correctly, but yeah, um, yeah. There's a lot of stuff that becomes a lot easier with Site 2. It's a bit more difficult to do with the old Site generation code, um,
mhm.
and because everything's using the same tile grid, can we can do more advanced stuff and combine a lot of different elements a lot easier. So, for example, um, we could have the ability for sites to have a boundary wall by just having um, the boundary wall occupy certain tiles around the town, and that would just fit sort of relatively cleanly over everything.
All right, and then one more question. If we get different house types based on location, how would the system determine what houses to build on what location, and what would happen if the town is located in two different biomes? So I think this is a little bit out of scope of what we're talking about today. If is that sure if you have like a two
Yeah,
sentence
so
answer, but
so this was going back to what I was saying about the structural stuff. How we actually generate the overall structure of a town is still a bit to be decided. I have some ideas, but if you're interested in looking into this and thinking more about it, I'd encourage you to get involved and uh, talk to us on the Discord or on Matrix or whatever, because there are a lot of interesting techniques that you could use. So the current approach that I tend to favor is having the town build itself up over time, over the course of the world's history. So the town would start off as like a simple farm or something like that. And then gradually over time, as more people move in or the population of the town increases, you'd get more and more houses introduced, and then the land would get reused for certain things that have um, higher economic value. So, for example, you'd get a town centre built in the centre, then the farms would move out to the outskirts and so on. But actually working out how to have such a system evolve with the economy system and so on is quite a complicated task, but also a rather interesting one.
yeah, there's a lot of people working on putting a lot of these systems together, but um, I think yeah, definitely our aspirations are very high for a lot of like combining combined systems and stuff, and so um, yeah, hopefully we can see more of that. And then also for anybody who wants, if you stick around after our stream is done, we'll be in the general channel in Discord where we can dive into some of the less related or out of scope questions. Um, And so, Zester, if we want to, we can get started with some of the code. So
Sure.
we're implementing a cube to start.
So I'm going to try to be quite quick with this because we don't have an enormous amount of time. So I apologize if I miss a few details about what I'm doing. But so what I'm going to be starting off with is I'm going to be creating a new file, or rather a new module called windmill. And just for ease, I'm going to copy and paste the workshop code into a new file. And then I'm basically just going to gut the entire thing. Actually, that. Wait, anyway.
If you want, I'll give you a few seconds to just type here without having to talk, and then I'll just answer some more questions that I see in chat that I can answer. So first of all, one question from Twitch. Coding question, do you guys use an ECS to make Veloren? We do use an entity component system.
We do.
And there's a lot of blog posts about this that we've written. It'd be cool if we could like tag them, but we are currently using specs, and so this gives us a ton of benefits on the client and the server for being able to store stuff in memory and quickly access it and quickly work on it. And so it's a very big paradigm in Rust to use entity component systems, and we're getting to make use of that ourselves. And our question. So are there any plans of implementing a world interaction system like building, mining, etc.? And so I think what this, or if I understand this correctly, it's about like will different NPCs in the game be able to do this kind of stuff? So for example, will an NPC be able to go build a building, or will an NPC be able to go mine?
Yes,
Yes, TM.
eventually.
Yeah.
But there are an enormous number of steps required to get that working in real time. For now, I think an earlier stage that we'll probably get to is the ability for the owner of a server to shut down the server and then run the simulation for maybe a few in-game years and then start it up again and have the world look different when players enter it again. Just because trying to actually display the construction of the house in real time is nightmarishly complicated, to say the least, and there are any number of ways in which it could go wrong or players could interfere with the process that cause all kinds of weird things to occur. So back to what I'm doing now. I'm basically just copy and pasting the code that generates the workshops and windmill. There we go. Instead of generating a workshop, we're just going to generate a windmill. And we need to create a new plot kind for the windmill. So everything changed? I hope so. So in plot.rs, I'm just going to get a new variant, which is about here. Okay, you can basically ignore the stuff I just did. It's just
templating,
changing and copying things in order to get things working. So now we should have our windmills actually being generated, but for now we're not actually generating any kind of structure for them. So what I'm going to do is I'm just going to copy the foundations that we had for the workshop. So workshops for reference look like all right, here. This is a workshop. It's not very good at the moment, but it is a thing. So what we're going to just do is try to copy the foundations here. So the foundation code is this. So we start off by defining a bounding box for the foundations, that's the bounds of the workshop, and it goes 16 blocks down to the ground in order to and we're going to fill the primitive with this particular pattern, which is the brick pattern, and this brick pattern is defined up here. How to describe this? This is basically just an automated way that we have of generating a nice brick pattern that's based on a certain color. So this color here is basically like a blue gray color, and it produces this kind of pattern here that you can see. You can see it kind of looks like bricks here. We have a few bricks that are inset into the wall. So let's be a bit creative and make this. So let's make it more like a terracotta brick. Let's change the color like this. And now we're going to recompile this. Actually, first, before recompiling, I'm going to change my waypoint so that we respawn this town. Yeah. So now, in theory, these windmills, quote unquote, are going to appear in the town. This file is a bit too big now. It needs to be made smaller. Here we are. Finally, so these windmills are going to be generated into the town, kind of semi-randomly in a similar place to shops were. And in theory, we should only see the foundation because we've not added anything else. I'm just going to recompile the server. What have I done? Undisclosed limiter. Go. Okay, I've not added the necessary import. Yeah, a lot of using Rust, trying something, getting a compiler error.
Yeah, you're playing on a hard mode without Rust Analyzer to give you a hand here and there.
Yeah. There we go. Seems to be at least compiling. So what I tend to do as well is, because we're not changing anything that affects the network game, I can just keep the same client open and then just recompile the internals, which is quite a bit faster than recompiling the entire game. So it just makes working on world generation a little, because you can iterate a bit faster. So this is just going to take a second. It's almost compiled. Now it's running through the generation process.
So these changes you're making, they're not being made to the client, they're just being made to the server that has to recompile.
Yeah. So world generation is entirely done on the server. So there's never any point where the client cares about how world generation is happening. The only thing it cares about is that you've sent it a bunch of blocks.
Mm-hmm.
And because we're not creating any new blocks, we're just changing how we put together the. Here we go. So we have the beginning of our windmills here. Nice red brick color. I quite like this color, actually. It's quite nice.
Yeah, not bad. And so I guess what happened here is that when it was regenerating, it still has all of these plots that it's allowed to put anything down on. And what you said is that you can put any of the 5 things that I already had, so houses, workshops, and other things. But now there's also a 6th thing you can place, which is windmills.
Yeah, yeah. Um, so yeah, this is just now another things that can go in a site. So eventually, we want there to be many kinds of site plot. So you might have different sites that have different um, generation rules that add different kinds of elements in different ways. So you might something like a necromancer tower that tends to put down plots that are more relevant to that kind of scene. So
Hmm.
you might have the main tower and then I don't know, like a dungeon next to it or something, uh, or like a goblin barracks or whatever the
Yeah.
hell you want to add to a necromancy tower. Or you could have something like a fishing village, um, like a boathouse there. And in time, we just like lots and lots of these different plots that can be placed in different ways, and the site generation code can make decisions about where to place these down as and when it wants.
Yeah.
So
Now we have 5 minutes left. I'm wondering, do you think it would be possible in this time to create, so in the middle of this plot, just create like this really tall, um, like small rectangle? So that could be like
let's have a go.
the middle of the
So
yeah. So
we're
let's see
going
what
to
that
start
looks like.
off by duplicating the existing rectangle. Instead of with a minimum set of base at the top of the foundations, and then we're going to give it height of say 32 blocks above the base. Um,
Oh, and sorry, can I get you to go to Discord again and just change to 30 frames per second, or whichever one you're not on? Yeah, that's perfect.
is that good now?
Hmm.
Okay, I
Yeah.
mean I've gone up the frame rate level, but sure. Um, so these these bounds here are the bounds of the entire plot, but we don't want our rectangle to consume the entire plot. So what we're going to do is we're going to add, say, 5 to the and subtract 5 from the maximum. That's going to make our rectangle a little smaller. What I'm also going to do um, is I'm going to create a hole in the middle. So
Oh, and so is
now I'm
this
just
using
going
the
to
technique?
code to get some ref. Let's do diff.
Ooh, I like this. I'm
So
very
I
excited to see
think
what this looks
diff.
like.
I think diff is the outside one. So what I can do is I can chain these methods together, basically. So
So as I read this, what I
build
see,
a pattern API.
so we have like the painter, and then we're saying, okay, we're going to start with an axis aligned bounding box, and it's going to have some dimensions, and so it's going to be a certain amount tall, and we're also going to say that the rectangle at the base is a little bit smaller than the size of the bounds. And then what we're saying is now that we have this tall rectangle, we're going to apply something else to it. So we're going to apply the difference of, we're going to just toss a square in the middle. And so essentially
Yeah.
we're just saying
So
subtract anywhere that they
what
touch.
we're doing here is we're building a bounding box that's very slightly smaller. So the way I've done that is just by adding 1 to minimum and taken 1 from the maximum. So let's change this to be more interesting. My phone is vibrating. Okay. Let's change this to be yeah. Let's make it more cream colored. Why not? Yeah. Uh, okay, let's try that. So the key. Oh, mess something up. Oh, I've been a bit stupid. Should be there. Um, Why is diff not found? Oh, it's a method on it was quite a while I wrote this code. I have forgotten how to use it. Maybe I didn't even implement that. Okay, what we're going to do, this should work, but right now I'm going to use the old way of this, is to do the following. It's basically the same code. It's, instead of using the nice chained method API, instead doing something a bit different.
So yeah, while you finish this up, one question from chat about the code. Why did you, so for like the colors, why did you clone it instead of just passing it into the function call? And I imagine it's just habitual.
Did I clone it? There was a reason. I think it's that one of the other options for a fill you have is this here, a sampler, which basically uses a predefined function that takes the position in and gives you back a block to fill the shape. That's used for certain things like placing down loot in dungeons and things like that. But you can basically ignore it for now. But
and then also Sinus
the
mentioned.
unfortunate thing is that
Yes,
cloning.
Sinus mentioned in Discord, I implemented diff and you implemented XOR, which are the same, but maybe you did not implement new wrappers for diff.
I might not have done. That is true. So as you can see, this API still needs a bit of work, really. It needs some.
Oh yes, this is why it's still in the you have to enable the feature for it. Yeah.
Yeah, it's been a little while since I've this code, about a month, so probably.
All right. So while you're getting
misremember a few things.
While this is all just loading in, since we're approaching time, I'll just put out a reminder for anybody still listening. If you want, you can come hang out with us afterwards in the general channel in Discord and talk a little bit more about some of the ideas behind this. We'll try to run this code reading club again. So if you have like any suggestions on what could be done differently or what you liked, what you didn't like, either just send them to anybody on Discord. I guess YouTube comments as well are probably pretty valid. But now, as we can see, so Zester has everything loaded up, and let's take a look. Interesting. Okay,
the color's a bit too green for my liking, and the dimensions are a bit weird, but you know, that's the whole point of things and trial and error. But
and so why are some of them super small, like super thin?
So I can just enable build mode and drill a hole through the wall, give us a door. So you can see you might use another bounding box here, and use another diff operation in order to make a hole for a door, for windows and so on. And after a little while, you find that you have something that's starting to look like an actual building.
Yeah, so there's a lot of instructions on putting stuff together.
Yeah. And this one I just generate on a really tiny plot. So this is the entire building. It's just a vertical. Nice.
Yeah, so I imagine that there might be some type of check that would say if we're building on something that's just small, or like, for example, this type of building requires plots that are at least this big.
Yeah, so the way I have this set up.
And sorry, you'll need to do Discord again. Oh, wait, no, it's better. It's better. We're good. It upgraded itself.
The way I have this set up is that there's a certain range of sizes to generate, and because workshops can accept a smaller size plots, and I just copied that code. It's using the workshop size. I could increase this to 9 or something like that, and then we'd end up with a bit of a larger plot for each one.
I see. All right.
Yeah,
So
I think
now, is there
those
anything else you
things.
want to mention about any of the site stuff before we wrap up?
There's a huge amount more to mention. Um,
Yes, of course.
I think hopefully this covers enough to at least make people interested in it. Maybe feel like they want to get involved and start working on this. Um, it's all very approachable, and uh, we're always happy to answer questions about things um, and help guide you through the process of getting involved.
Yeah, for sure. So I think
Yeah,
definitely anybody watching this, if you're interested in contributing different types of building or playing around with this, there's definitely a lot of people who can sort of mentor you in getting some creations done for either villages or out in the wilderness or anything.
yeah,
Also,
definitely. I mean, it's quite an adaptable system, so you can
yeah,
build anything that your heart desires with it.
absolutely. One more thing about or from chat, they're wondering if you can push this to some branch so that other people could take a look at the code changes you made. So I'm sure you
Yeah,
can do
sure.
that after the.
I can put that on a windmill branch or something.
Yeah. All right. So I'm gonna wrap up the um, today's code reading club. And so thank you, Zester, for taking the time to walk through some of this, and hopefully we can be back either on a bi-weekly basis or something like that to have more of these types of things where we can bring people in on seeing a little bit of what the code looks like. So thank you very much, Zester.
Yeah, I look forward to it.